What does the term weaving conjure up in your mind? That hand loom you saw in the Crafts Museum on your last holiday? Factory halls of the late 19th or early 20th century, when weaving rapidly became a core technology of the first great industrial revolution? Or perhaps the pleasure you gain from fashionable dressing? Or an industry which still enjoys international importance and which supplies billions of people with clothing fabrics? Just think about something quite different. Something which will hopefully never happen to you.
In front of your head, your knees, at your side, your car's airbag inflate within milliseconds of impact to protect you from the consequences of an accident. Propelled by gases produced in a controlled explosion, they inflate within split seconds to prevent the unbraked impact of your body against the highly rigid sides of the car passenger compartment, and so absorb the forces propelling you as gently as possible. Airbags, a significant advancement in the field of automotive safety, which would never have been possible without one thing: today's high-tech weaving technology. Just 20 years ago, it would not have been technically possible to produce the woven fabrics used to make airbags, nor that required to produce bulletproof vests, nor the fabric which lends ocean-going racing yachts and racing cars the stability they need, despite their no-compromise lightweight construction.
Weaving, an ancient technology for the manufacture of textile surfaces with a stable inner binding of warp and weft threads. Let us watch an animated demonstration of the principle of weaving.
The frames in which the heels are suspended are known as heeled frames. Together, these form the loom harness. At least two heeled frames working in opposition to each other are required for weaving. A warp thread runs through the thread eyelet of each heel. When the heeled frames are raised or lowered with their warp threads, the so-called shed is formed. The weft thread is then drawn through the shed using any one of a variety of methods: by projectile, by shuttle, air, or water. The reed then presses the weft thread against the woven fabric. The warp threads are then moved to the opposite position, across each other. That is to say, those that were up move down and vice versa. This crossover process fixes the weft thread to create a permanent weave.
The heeled frames and heels are subjected to extreme levels of wear. They are raised and lowered up to 1,000 times a minute and have to withstand acceleration levels up to 9 times that of gravity. At the same time, extreme material care must be taken of the warp threads if a high-quality weave is to be achieved. In brief, this is another case for precision mechanic specialists with highly specific technical know-how. A case for Gros Poggen. This Swiss specialist in weaving equipment, founded in 1891, has been a member of the International Grossbecker Group since the year 2000 and offers a wide range of products serving both the loom building industry and the weaving mills the world over, with original equipment and spare parts. And a case for Schmeing. This renowned specialist weaving equipment firm, which supplies not only heeled frames and heels, but also high-grade plastic components, has also recently become part of the Groats-Beckert group of companies.
Let us take another look at these components at work in a high-tech weaving machine, or more precisely, on an air-jet loom, in which the weft thread is projected with the aid of precisely metered air jets at a speed of over 180 kilometers per hour through the shed between the warp threads, 1,000 times a minute. This clearly demonstrates the kind of stress to which heels and heeled frames are exposed, because it is these parts which are responsible for 1,000 shed changes per minute in 3-shift operation around the clock. It is only when these vital components, which are the only ones in direct contact with each individual warp thread, perform their task precisely, reliably, and taking optimum care of the yarn, that it is possible to produce fabric in line with the stringent standards demanded by modern clothing fabrics and technical textiles. Of primary and decisive importance for the quality of the produced fabric is the shape of the heels and the thread eye through which the warp thread is guided. The more precise the guidance, the lower the friction, the more warp threads fit together over a given distance, and the better this is for producing extremely fine and dense fabric. And the lower the vibration and torsion to which the heeled frames are subjected, the better the overall weaving result, which naturally also contributes towards improved economy, as heeled frames capable of withstanding high loads permit greater production speeds.
It is precisely in these areas that the technical expertise of Grope and Schmeing is brought to bear. A whole series of patents, continuous improvements, heeled frames and heeleds from these specialists offer optimum performance and economy just where they are needed, at the high end of the weaving industry. But in the mass production sector too, where the emphasis is on the production of simpler fabrics, they both also offer heels of outstanding quality for practically all existing loom types. Plus, precision-engineered techniques for warp thread monitoring, all of which adds up to the best possible business outlook now and in the future. Because even if the number of weaving mills in Germany and Europe is declining, the number of people who make use of industrially produced textiles is on the increase. And while the market for woven fabrics is growing inexorably on a worldwide basis purely for the reasons of demographics, technical textiles are also finding a growing market in ever-new technological fields.
Without them, there would be no space travel. Without them, there would be no firefighting suits. Without them, we would not benefit from many things which make our lives safer and more comfortable. A silent revolution in which Groats-Beckert, too, is playing an instrumental role through Grope and Schmeing. As part of the international Groats-Beckert group, these two weaving accessory specialists generate a substantial added value in terms of know-how in the field of precision mechanics. Know-how with a great future for us and for the world as a whole. Groats-Beckert.